Welcome back to Bruns's Math Club. Today we'll be learning how to solve systems of equations using graphing. When you're solving a systems of equations, you're looking for values for x and y that you can plug into both equations given and that the equations will be true using those values. There are three methods that you can use to solve a system of equations, and one of them includes graphing. And so today we'll be learning how to solve the system of equations using the graphing method. The first step when you're solving a system of equations using the graphing method is to make sure that your equations are in slope-intercept form. Slope-intercept form is y is equal to mx plus b. The m stands for the slope, which is rise over run, and the b stands for the y-intercept, which is when the line of the equation intersects at the y-axis on the graph. Here we have two equations which are y is equal to 4x plus 3 and 2 is equal to negative x minus y. We see that the first equation is already in slope-intercept form, but the second one is not. The second one is 2 is equal to negative x minus y. In order to get this in slope-intercept form, we need to make sure it's in y is equal to mx plus b. Here we see that the y is on the other side, and we need it on the left side, and then we need the b, which is 2, on the right-hand side. Let's go ahead and move the y onto the left-hand side by adding it, because since this is a negative y, if we add y onto both sides, it will cancel out over here and we will be left with y plus 2 is equal to negative x. If we subtract 2 onto this side, it will cancel out over here because plus and minus 2 cancel each other out, and we'll be left with y is equal to negative x minus 2, which is in slope-intercept form. Alright, now that we have both of the equations in slope-intercept form, let's go ahead and graph. So we had y is equal to 4x plus 3, and we have y is equal to negative x minus 2. First thing we need to do before we graph is identify the m and the b values. We know that m is the slope, which is 4 over 1, because remember, it's rise over run. If it's not in fraction form, that means it's always going to be over 1 because it's a whole number. And then b is the y-intercept, which is 3. For the second one, we have m is equal to negative 1 over 1, because if it's just negative x, that means it's going to be negative 1, and then over 1 because it has to be rise over run. And then b is negative 2. First, let's go ahead and graph the first equation, which is y is equal to 4x plus 3. We know that 3 is the y-intercept. Let's go ahead and graph that first. So the point will be over here at positive 3 on the y-axis. Next, we'll graph the slope, which is 4 over 1. That means we're going to go up 4 from the y-intercept and over 1. So it will be 1, 2, 3, 4 over 1. And then 1, 2, 3, 4 over 1. We can go down too, but this time we're going to have to flip the equation sign, the slope sign. So if it's positive 4 over 1, it will become negative 4 over negative 1. That means we're going to go down 4 and then to the left 1. So we will go 1, 2, 3, 4 to the left 1. 1, 2, 3, 4 to the left. 1, 2, 3, 4. And I think we can do it one more time. 1, 2, 3, and then 4 over 1. So this is the line for the first equation, which is y is equal to 4x plus 3. This isn't perfect, but this is where the points really should be. Next, we have y is equal to negative x minus 2, and the m is negative 1 over 1, and the b is negative 2. First, we'll graph the y-intercept, which is negative 2, so it will be down here. And then we'll go ahead and do the slope, which is negative 1 over 1. So down 1 and then over 1. Down 1 over 1. And we could really continue this all the way down. So let's go ahead and stop here. Now let's go in the opposite direction. So that means we're going to have to go up 1 and then to the left 1. Up 1 to the left 1. And we see that one of our points is intersecting with the points in our first equation. And if we were to go again up 1 over 1, it would go over here. And we can go ahead and stop plotting the points now because we've found our solution. We know that the point of intersection, we found it, which is going to be negative 1 and -1. So our solution is -1, -1. That means that if we plug in that value of x as -1 and the y as -1, so this is x and this is y, then both of the equations should be true. Let's go ahead and test this. So if we have y is equal to 4x plus 3 as -1 is equal to 4 times -1 plus 3, and then if we have y is equal to -x minus 2 as -1 is equal to negative and then times -1 minus 2, we plugged in the x and the y values. Now let's go ahead and solve these. So we'll get -1 is equal to -4 plus 3, and we get -1 is equal to -1, and we see that the first equation is true. Here we have -1 is equal to -1 times negative, which is also a -1. It becomes +1 minus 2, and -1 is equal to 1 minus 2, which is -1, and this is also true. That means that our solution is true. So the solution to this system of equations is going to be -1 and -1. That means these points are going to make both equations true. And so this is it for this video on solving systems of equations using graphing. Thanks for watching, and we will see you guys next time. Bye!